you can able to complete today. Explanation of IP address is also there video. Just go through once if possible. Okay. Again, so we discuss up to session layer. From fourth layer, we can discuss again once again OSI open system interconnect OSI reference model 7-layer model. It is contains 7 layers. So application layer, presentation layer, session layer called as top layers or upper layers or software layers. Network layer, data link layer, physical layer are a bottom layers and hardware layers. The middle one's transport layer is also called a heart of OSI layer. It provides end-to-end connectivity. So totally 7 layers. Always read application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So what is this application layer? Application layer deal with the applications and protocols and their port numbers. What is this application? Server side application, client side applications. For example, web browser is a client side application. What is the use of web browser? To open a websites? Okay, do you want to see the website web content? We use a web browser. But who is providing that information? Web server. Web server is built by the respective applications like Microsoft IIS, HTTPD, Tomcat, so many applications are there. Mail servers, for example, mail communication. I want to send and receive mails through my mail client application. So example, Outlook. Okay. And mail servers. Different applications like a Microsoft Exchange application is there, Zimbra application is there, Squirrel Mail application is there. So different mail server applications are there. And so Outlook is a mail client and there is a Microsoft Exchange or a Zimbra mail server. But how they will understand this is the client side request or a server, how server will understand what is the request by protocols only. Okay. From mail client will send a request. SMTP means I'm sending a mail to mail server. Then mail server understand the client request by SMTP. A client is sending a request like a POP3 for example. So server understand client asking for a downloading mails like that. Similarly, FTP server is there. FTP vs FTP server is there. FTP applications are there, right? Client side applications are there. So I want to upload a data into the FTP server. So I'll put it in a FTP FileZilla application, Qt FTP or a Duck FTP something. I put a data there and give the FTP server. Data is uploaded to FTP server. It is a client and server applications and protocols. Okay, so there is a different protocols we are using like HTTP, HTTPS, FTP, SSH, Telnet, RDP, SMTP, POP3, IMAP, TFTP, DHCP, DNS, NTP, Kerberos, LDAP, SNMP protocols. Not only these protocols, there are several protocols are there, but least to least know the some regular protocols. Okay. So protocols, client side application and server side application. Yes, for example, I'm getting a page like this. I open a page. It is showing 404 page not found. Okay, 404 page not found. What is the meaning? It you send a request. You send a request to the server. Server do not have that web page. what it will do it will send 404 page not found. Okay, example for a troubleshooting, understanding troubleshooting, you received a page not found, 404 page not found. Meaning is your internet is good. Meaning is your internet is good. Only thing is either your website or maybe your URL problem in maybe in this URL. Okay, or maybe this particular URL is removed. This particular page is removed in the server, or maybe you are given a wrong name. Maybe server application has some problem. Server application may have some problem. Some application related some problem is there. That's why you are getting 404. So if you are getting 404 page not found, meaning is not 100% your mistake. Your side problem is very less. Means you are having internet first of all. No internet problem, so no need to connect and disconnect kind of stuff. Only check the URL, make sure that URL is correct or wrong. Okay, once it is confirmed, it is a correct. It meaning is your side problem is not there. It can be a server side problem. It can be a server side problem. So like that, we can understand where is the problem, server side or a client side. For example, I have a mails. I'm having a mails, right? So I am able to send a mail, and as well as I'm able to receive a mail. Means my server and client configuration is good. I am unable to send a mail. First of all, check the internet. Internet is good, so I can able to open different web pages, websites. I can able to open. So my internet is good, but still I cannot able to send or receive any mails. Meaning is it can be a problem with your Outlook client application, or a configuration in the Outlook, or maybe server side problem. The first time, so we are using a client side, right? We are sitting at a client side. So we will check at a client side any configuration changes or any other different issues are there. Okay, any configuration changes, connectivity changes. Okay, so please we will check it. Once we check everything, confirm. So we'll cross verify with any other PCs or any other IDs, email, password kind of stuff. Then it is, we can confirm it is a mistake is by me or others. Okay, mistake can be in Outlook, or maybe the some missing mistake will be there, or it can be a server related issue. Okay, so here it is. So easy troubleshooting from using OSI layer, application layer, presentation layer. So what is the next one? Presentation layer. So when you are sending and receiving a data, so at the time of sending, so top layer, right? Application layer, then presentation layer. So it encoding data. So what are the data format? It convert into ASCII format, and decoding data. So when the data coming from the session layer to presentation to application, data is decoded. Data compress and decompress, encrypt and decrypt. So you may use a protocols like instead of HTTP, you use HTTPS. Encryption is required. You may use SSH instead of telnet. That is may required encryption, right? So like that, for example, so you are required to encrypt the data at presentation layer only. Data is encrypted. Next one is session layer. Session layer means when you open a web page. So for example, you open this website. Okay, you open the website. The request go to this web server. Okay, to when it is sending a request, that time only in our PC a session is created. So request went to the web server, and request is sent completely. So then server received, and server returns with some page. So server return a information. So once we receive the information, then session is completed till the time session is maintained. For example, you download a 100 MB file. Okay, so you're initiated a click on a download. So you click on a download, right? So like that, you send a request and you click on a download. Now file is downloading and download is completed. Okay, so session is created and maintained, now terminated. Session will be terminated sometimes by disturbance in the network, like a connect and disconnection, power cuts, okay, network disconnections, okay, or a internet down kind of stuff. Okay, so session layers automatically terminate if any network related disturbances occurs. For session layer, there is a very good example is also there. I'm not telling now. Okay, so we'll go to the transport layer. So from here we have to start actually, but just I'm trying to explain once again. I don't know what I explained earlier also. Okay, so transport layer is providing end-to-end connectivity. It segments the data. Segmenting means it cut the data into small parts, small pieces. Must be above the 64 bytes. And each part will be arranged in a sequence order, and it is given each piece of data having some numbering on it. So it is used easily for ordering, and also it is used for a error correction. So transport layer do error correction. How it will do? For example, here you can see hello, how are you is there, right? You can see there's a packet called. So I am sending a message, hello, how are you? This is the message. So segment layer, just for understanding, it cut it into 4 parts and it is putting a number. This is also just for understanding. Now 4 parts are created. 4 parts are created. Now what it is? Okay, now what happened? When I'm sending this messages, this thing to the some destination, he received a hello and how and you. What happened? So whenever this destination received a hello, it sent an acknowledgement. Yes, I received 1 by 4. Like a packet 1, I received 1. I received 2. I received 4. By 3 is missing. So I understand, this source understands third packet is missing. It forward the third one like a R. Now it is received. Yes, third is received. Now all packets are received, good, but not in the correct order. So how to arrange the order? Again, because of the sequence number. So again, it will order hello, how are you? Again, this will be here. So it rearrange the order like that. So that's why the transport layer also do error correction. So it will find out any data is missing, it will try to resend it. And using this numbering and sequencing, it will order the data into proper order. So it will be error correction possible. Multiplexing and demultiplexing of a TCP UDP protocols. So here it is also a misconception is there. Guys, TCP UDP are protocols, and lot of protocols, like what are the protocols we discussed earlier, those protocols, okay, those are that kind of protocols. Some are TCP type protocol, some are UDP protocols. Some are TCP protocols, some are UDP protocols. Okay, TCP type protocol, TCP, SMTP, FTP, okay, like this. These certain protocols are a TCP type protocol. DHCP, DNS, TFTP, these are all UDP type protocol. What is meaning of TCP type or UDP type? TCP type protocols, it is a very straight explanation, guys. Actually, there is a synchronization, asynchronization, acknowledgement. Big story is there. I'm not going that one. So TCP type protocols, sorry, UDP type means the UDP type protocols behave like this. So whenever source, whenever we send a source to destination, when you send a packet, once destination received a packet, whenever the destination received a packet, immediately, okay, I send a packet at a destination, received a packet, it will send an acknowledgement. It send a acknowledgement. So source send a packet, destination sending a acknowledgement. Yes, I received this package. So source send a packet, destination not received a packet. So what it will do? Nothing. Again, source send a packet, source send a packet. So it's a source will continuously deliver the packet because small packets, right? So the destination received a packet. Then it will send a acknowledgement for the latest package. So I didn't receive the acknowledgement for this particular packet. So then I can understand this particular packet is dropped. Some network disturbance, this packet is dropped. Okay, so what it will do, it send a packet again. Okay, of course it will be rearranged after collection of all the parts of packet or all small packets. Okay, so this is TCP type protocols function like this. UDP is very easy. UDP, source send a packet, destination received it. Source send a packet, destination received it. Source send a packet, destination is not received or no, we don't know. Okay, and source send a packet, destination received. Source send a packet, destination is received. So if you are missing a data to the destination unable to receive a data, source don't know, destination is unable to send. Source don't know, unable to send. Okay, so source think destination received it. Source think destination received it. Source don't know whether destination is received or not. Okay, because of destination not sending any acknowledgement. Okay, so in this case, its acknowledgement depend. So source don't receive any acknowledgement from the destination. So source think, what is source think? Okay, this particular packet is not received by destination. Okay, so then we will have to send it again. But in a UDP type protocols, you send a packet, that's it. We don't mind about whether it is received or not. That's why it is TCP is a acknowledgement based protocols. UDP protocols are a no acknowledgement based protocol. And connection oriented and connectionless. Guys, connection oriented and connectionless means it is a two-way interactive method, right? Connection oriented means it's a two-way interactive. Source and destination both are interactive, like a source sending, destination receiving, and destination telling I received it. So two-way interaction is there. That's why it is called a connected oriented protocols. It does not mean it's a wired protocol, wireless protocol and all. No. Okay. Connectionless protocol. Connectionless protocol meaning is okay. So connectionless protocol means one-sided story, like one person is talking, other person is just listening or sleeping, we don't know, right? Okay, so that is like a connectionless protocol. And TCP type protocol is a reliable. UDP type protocol is non-reliable. Why non-reliable? We don't know whether destination is received a packet or not. Example I will tell guys, very simple. Acknowledgement meaning is like a in a olden days when we are in a very olden days kind of stuff. So you want to apply an application for like a gate exam or some examination or for job applying. So you have to take a paper or a application form. You have to fill it and attach a acknowledgement slip. Okay, then we'll post it with the stamps on it. Okay, so whenever the at the receiving side, whenever he received, so what it will do, you open the application, you open application, see the application, there is an acknowledgement card. You'll repost the acknowledgement card and I will receive the acknowledgement card. Once I received, I understand, okay, he got a received it. This is original acknowledgement method, but here in this one, I'm telling very simple. Message delivery system, notification system, your item is delivered successfully. Okay, your message delivered very successfully. Check marks, see it is. Check mark means everybody received this message, but not everyone see this message, right? So when you see like this kind of check marks, so meaning is, okay, whenever you see a green check marks, meaning is people are received a message. Okay. Okay, so then it is like a check mark. Delivery system, reply or acknowledgement system, meaning is destination received a packet. I didn't receive any particular acknowledgement, meaning is destination may not be received a packet. So how to send the packet again? So that is a acknowledgement based communication. Because of this two-way interactive method, means sending and receiving a acknowledgement. Because of that type of communication, we call it as a connection oriented communication. It does not mean wired or a wireless. Even my college days, people telling an example for a connection oriented means it is a wired, connectionless means wireless. For example, I'm using Wi-Fi. I'm using Wi-Fi connectivity. So I open a website using HTTPS. It is UDP. That is wrong. That is what I'm saying, wrong. What is the correct one? Connectionless protocols. Connectionless protocols. Okay. Meaning is it's a type of protocol. It means whenever it is send a packet to the destination, so we don't know whether destination received a packet or not. That's why it is called as a connectionless. Connection oriented. Okay. I hope you got the point. So I spent a lot of time here only. Reliable, non-reliable. So it will multiplex TCP and UDP type protocols. When it is communicating, you may use a different type of protocols. So then we'll multiplex TCP type protocols into TCP. Box will be there, so we'll put into that one. UDP into UDP. Okay. And also transport layer will do flow control or a windowing. So what is this flow control or windowing? It estimates the destination receiving capacity. Based on that only we'll send the packets. Otherwise what happen? For example, you are 1 Gbps. Your destination is only 100 Mbps. Lot of packet data loss will be occur. That's why we will estimate the speed of the client can able to receive, or a destination can able to receive. Based on that only we'll forward the packets. Okay, PDU means packet data unit. Data in the any layer like application layer data or physical layer application layer data, a presentation layer data, session layer data is, we can call it as a packet data unit. Same thing, data in the transport layer is also called as a packet data unit, but that packet data unit will be added with a TCP header, which contains protocol informations, segmenting, sequencing, numbering, all information is added to your PDU. So then it is become a segment. The transport layer generate a PDU called segment. The segment contains TCP header. This segment will send to the network layer. In the network layer, actually dealing with the routed protocols and routing protocols. Routed protocols means IP addressing kind of stuff comes under routed protocols. Routing protocols are to reach the destination, we need a routing protocols. Different type of routing protocols are there. So like RIP, eigrp, ospf, BGP, ISS, and default routing protocols also there to reach the destination. So this information will be added to your segment. Network header will be added to your segment. So the network header is nothing but your source IP and a destination IP. Okay, source IP and destination IP address of a source and destination PCs, IP address will be added to your segment. Okay, source IP plus destination IP plus segment become a packet. So our PDU is become packet. This packet is sent to the data link layer. Data link layer. In a data link layer, there is a two layers are there, LLC and MAC. Logical link control. Logical link control. So what is this LLC part? Actually, if you are connecting to internet directly, okay, so we use the connectivity protocols like a PPP, HDLC, frame relay, and MPLS type of protocols. So LLC is dealing with WAN protocols. MAC is dealing with, already MAC address, media access control, which is the MAC address is available on a NIC. Okay, so it is dealing with a MAC address, source MAC address, destination MAC address is added to your packet as a data header, and there is a data tail here, that is a CRC. Okay, so CRC means cyclic redundancy check. It is used to for error checking purpose. Here it is. When you are sending a packet, once destination received a packet, first it will verify the data errors. Any packet is damaged or errors are there, first CRC will check it. At which layer? Data link layer. Okay, so source MAC address, destination MAC address plus packet plus CRC become a frame. The frame is sent to the physical layer. The physical layer frame is converted into bit stream, and this bit stream again convert into either electrical signal, radio signal, or radio waves, light waves. Okay. Okay, so like if you are using fiber channel, light waves are important. You are using Wi-Fi, radio signal type are important. You are using Ethernet, electrical signals are important, guys. So this is about your OSI layer. So I am the only, this is my, I think so, maybe first time or second time I took a OSI layer with a very less time period. But try to understand each layer has a one or two unique things. So find out, read it, and practice it. Okay. But I want to tell few more points. That is, look at this is the PCA and that is PCB. You want to send a ping command, ping based on a ICMP protocol. Ping is a command used to test from source to destination. So whether we can able to communicate or not. So it uses ICMP protocol. So whatsoever it is, the first where you put a ping command. So in a generally command prompt, right? So this is the application. In this application, I am putting a command, but the response is go with the ping mechanism. Okay. Sorry. So what are the data in application layer? What is the protocol? ICMP protocol. Okay, which application, CMD application, where to reach the PCB kind of stuff. So in a presentation layer, so data will be compressed and data is encrypted, data is converted into ASCII format. So then data is given to the session ID. So session ID is start understanding what is PCA request and create a session with a PCB. This session will be there till the PCA, the required page is open, for example. Transport layer. So what it will do, it will take the data and cut down the data into small pieces, and it is called a segment. Sorry, it do segmenting, and also it they kill. Okay, in a transport layer will be added with the what are the things will be added in transport layer network TCP header to the PDU, then it becomes segment. That segment is in the network layer, it will be added with the source IP, destination IP to the segment, then it is, we can get a packet. Data link is actually source MAC address, domestic MAC address. What I'm speaking, source MAC address, destination MAC address, packet plus CRC is become a frame. The frame is sent to the physical machine. Sorry, physical layer. The physical layer contains a bit stream. Convert the frame into bit stream. So, for example, I am using wired connection using electrical wires. So, I send a packet through wire to the PCB to the physical layer only. In physical layer, it converts that electrical signal into bit stream to frame. Frame is forward to data link layer. Data link layer verifies source MAC address, destination MAC address. Using CRC, it will verify if data contains any errors or not. Next one is a network layer. So once the packet is divided from the rest of parts, so then that network layer check the source IP and destination IP and collect the segment. So that segment is given to the transport layer. So it will verify the which protocol they are using, what is the sequence number. Okay, it reassembles at a transport layer. The session layer understand the session ID of the PCA, and it is also establish a new session and give it to the presentation layer. If data is encrypted, it will decrypt it. Compressed data will be decompress it. Okay, like this. So it's a presentation layer. Okay, it will decode the data from encoding, right? Next, what are the data is there? It is given directly application layer. Application layer. So it is generate different type of responses depends upon the application. Okay, guys, that's why I told already. You study from application layer to physical layer. That is one method, but you study a physical layer to application layer. That is a different method. You can use any method. This is a difference between OSI layer and TCP layer, guys. Application layer, presentation layer, session layer. The duties of application layer, presentation layer, session layer is application layer in the TCP IP protocol suite, also called as a DoD model. Transport is transport, New York is internet, and data link layer, network access, and physical layer. So physical layer and data link layer is equivalent to network access layer in a TCP IP, and network layer at OSI layer is become a TCP IP. Internet layer. Transport is transfer. Okay, but in the first three layers, application, presentation, session layer merged into only single application layer. This is the layer wise troubleshooting, guys. Layer wise troubleshooting. Okay, and here it is some commands explanation. This is the ping command. Okay, so that's it for this OS layer. Anybody having any doubts, understand or not understand OS layers?
Sir, physical layer.
Physical layer. Okay, physical layer basically on a physical connectivity. Like you are using a Wi-Fi. Okay, then it is a physical connectivity. So your data, your bits converted into wave format, means radio signal format. It will try to connect with the radio frequency. Wired, you are using a wired connections. Basic that related electrical signal is enough. Okay, some people use like a fiber channels, where big data storage, faster data transmission kind of stuff. So we use a fiber channels. So fiber channel work with light waves, so it will convert the data into light waves. Physical layer, actually it is the physical device, direct device. Okay. Anything? Any doubts? I will explain the ping command tomorrow, so you can read. First you read, I will explain later. Okay, and also so check the IP address, guys. What is an IP address? Okay, classes of IP address. And the important is an IP address also. What is an IP address? Classes of IP address. What is an IP address? Class of IP address. IPv for how many bits? IPv6 how many bits? That question is also there. Important is ranges. Okay, and subnet mask for IP addresses, private IP, public IP addresses. Okay.
Okay, sir.
Yes, sir.